Take 95 from Mr. Goubino here. We're going to be going over the circuit training. So we're going to go over this document right here. I have done it and I will post it onto the Google Classroom. I just want to go back through. There's a couple problems that I just want to kind of go over so that you are feeling pretty comfortable with doing those types of problems. And most of them are with the implicit differentiation. So we're going to get started here. I'm going to do 3 problems, and then if you have any other questions, you're going to let me know. So the first question that we're going to do is number 4. It says x times y is equal to cosine of x, and we need to take the derivative of this function. If you notice over here, we have the product rule, and then we just have a regular cosine. So what we are going to do is we're going to find the derivative of this dy dx. So what they're looking for is dy dx. So we want the derivative of y in terms of x. So anytime that we have a variable that is not an x, for example that y, we have to add the dy dx. So the product rule, the first times the derivative of the second, and the derivative of the second is 1, but since we took the derivative of y, we must include the dy dx. Plus the second, which is y, times the derivative of the first, which is just 1. And then we're going to find the derivative of cosine of x, and the derivative of cosine x is negative sine of x. And because it's not in terms of y, we're going to leave it as that. So the object again is to get dy dx. So anything that doesn't have a dy dx is going to go to the other side. I'm going to keep that with that. Subtracting y, it doesn't matter which way in this case you're subtracting. You could do negative y minus sine x. And then in order to get dy dx by itself, they are going to divide by x. Now, I believe what they did from this point was they factored out the negative 1 in the numerator. I'll put it up here. So they get sine x plus y. So if you look for that, the negative 1 times the sine x plus y divided by x, that would be your answer. And that leads to number 5, which is the next problem that we are going to do. Okay, in number 5, we have x squared plus y squared plus 2 cosine x equal to 32. So question 5, the 5th problem that we have to do, that is on the second page in the bottom left, and we need to find dy dx. So what we're going to do is, again, anytime that we are looking for derivatives of y's, we need to add a dy dx. The derivative of x squared is just 2x. The derivative of 2y is 2y with the derivative of y in terms of x. Now I'm going to put a plus 2, and then this derivative is negative sine of x. I'm going to put a parenthesis because it looks like 2 minus sine x if I don't. And then the derivative of 32 is just a constant, which is 0. So we have, just cleaning this up a little bit, you don't have to, 2x plus 2y dy dx. That's dy dx minus 2 sine of x is equal to 0. Anything that does not have, anything that does not have a dy dx, we take to the other side. So I'm going to add 2 sine of x, subtract 2y, and that equals 2y dy dx. And then I'm going to divide by 2y, so dy dx is equal to 2 sine of x minus 2x over 2y. And obviously in this case you can see that you can cancel out a 2. So look for the answer of dy dx equal to sine of x minus x over y. Alright, and the last one is number 14. This is the last problem to do because it'll lead you back to the first problem. And we know that the answer for the first problem, because that's the one that's left, is going to be cosine of x. So we got to make this derivative be cosine of x. So we're going to take the derivative. We have a product rule. The first, which is tangent of x, times the derivative of the second, which is negative sine of x, plus the second, cosine x, times the derivative of the first, which is secant squared x. Now, with this, we have to do a little bit of Pythagorean identities, trig identities, whatever we need to simplify this. So what I'm going to do is I'm going to change everything into sine and cosines. So this is sine x over cosine of x times negative sine of x plus cosine of x times 1 over cosine squared of x, because secant is 1 over cosine. So far so good. I'm going to multiply the tops. I get negative sine squared x over cosine of x plus cosine times 1 divided by cosine is 1 over cosine of x. Okay, because I can cancel one of those cosines. And if you look, I have on the top f prime of x is still equal to, negative sine squared x plus 1 over cosine of x. This is the Pythagorean identity. That Pythagorean identity is cosine squared x over cosine of x. I am going to cancel one of the cosines, and I'm going to be left with, yep, you guessed it, cosine of x. So that will lead you back to the first problem. Now, as you're doing these problems, if you do get stuck, just let me know. Most of these are simple derivative formulas. Some have a little bit of product rule. I didn't see too many quotient rule, and there are implicit differentiations. So go ahead and look at this one. If you have any questions, please let me know.